communicating warning information in HTTP APIs. My name is Cedik. I'm a product manager and developer advocate at ShipCloud.io. We're a shipping service provider. This means we're connected to all the relevant shipping carriers like DHL or UPS and are making them accessible via a single REST API. So we're basically what one would call the Stripe or PayPal for shipping. In addition to creating shipping labels through our API, we're also using the carrier web services for tracking your shipments, making it possible to know where the parcels are throughout the shipping process. When we started to work on version 2 of our API, there were obviously a few things we wanted to do better than the first time. Of course, the plan was to incorporate our learnings from maintaining our API over all those years. One major goal we had was to make it easier for new and existing integrations to work with our service. And while we were at it, true internationalization should be achieved, which meant making it possible to return translated strings in multiple languages. This would also mean a first step into making it possible to use our service in a true white label fashion. But what we needed most of all is better error communication to our API users. This is the way we currently communicate errors to our API consumers. Specifically when a third party, in this case the Deutsche Post, returns an error. We're showing an array of error messages inside an errors object, which is neither a particularly beautiful nor useful way of doing it. It's especially bad when you're factoring in that consumers of our API will have to communicate this to their users. And even worse when you want to provide an API that can be used in multiple languages. Let me quote the late Joe Armstrong from his GoTo conference talk in 2018. Building fault-tolerant software boils down to detecting errors and doing something when errors are detected. Which is a very fitting quote, I think. Isn't that what we all want? That errors get communicated to us as they happen so we can do something about them? Unfortunately, error handling in APIs is done in a lot of different ways at the moment. So let's dive in. HTTP response status codes are one of the most basic things communication between systems relies on. We all know they have 3 digits and are categorized into 5 main groups that start with the numbers 1 to 5. For error communication, the status codes in the 400s and 500s are relevant, which represent client errors and server errors. Unfortunately, there is nothing in between. This means error handling is done in a binary way. Requests either fail or they are successful. But there's a lot of stuff that can't clearly be defined by one of those status codes. One of the most problematic things regarding API usage is that every API provider is doing error handling their own way. Let's have a look at how error handling is done in some of the most notable APIs right now. Let's get back to our example from the beginning. So what's bad about this? We're returning multiple lines of error messages without any information about their severity. The first error message points more to an error on the client side. So when described as an HTTP status code, it would be more like a 400 bad request. And the second error message sounds a little bit like it has to do something with authentication. So its status code would be more like a 403 forbidden. Also, using this approach of just returning multiple strings as error messages, it's nearly impossible to have them be translated into another language without doing a one-by-one mapping. Squarespace is handling errors by adding attributes to the root of the response. Categorization in type and subtype makes it easier to group errors. So maybe you only want to handle a specific group. They have an attribute called message as a way to transmit a short message to the developer. and a details object that is intended for machine readable usage in generating user-friendly error messages. One particularly good thing is that they are providing a so-called context ID, which you can use to contact their support team in case anything happens. Facebook's Graph API encapsulates their error communication also in an error object. This shields it from the rest, so errors and other response data doesn't mix. They have code and subcode attributes, which are used similarly like type and subtype at Squarespace. This again makes grouping of errors possible. Aside from code and subcode, they have two attributes called message and type, which are strictly there for developers to find out what has gone wrong. So you won't be using them to display an error message in the front end. Error user title and error user message can be used for showing the user what has happened. What's cool about this is the language of the message is based on the locale of the API request, which you can't see in this example. So you don't have to worry about translating error messages for the locales you're supporting. Just like Squarespace's context ID, Facebook returns something called FB Trace ID for communicating with their support. Facebook's marketing API uses the same structure we just saw, but they're expanding it by adding an object called error data. In there, you have an array of arrays called blame field specs that shows where the error originates from. Here's a more complex example of what I just showed you, where you are seeing errors in two different places. As you can see, the blame field specs look a bit like JSON pointers, but they're obviously different. I'm not sure why they didn't use JSON pointers, but having something to pinpoint the origin of an error is worth a lot. When you look at the error handling of Plate, you can sense a common pattern. Plate also has an error type, which is a string where a set of predefined values can be returned. So error type can be something like invalid request or rate limit exceeded or API error. Each error type has a specific set of error codes. So drilling the error down to more finer grained messages is possible. The error message is a developer-friendly representation of the error code, and the display message a user-friendly representation. So once again, when you communicate to their API as a developer, you probably get more information from the error message, and when you communicate an error to the end user, the user agent, you would use something like the display message. Okay, the payment service provider Adyen uses a similar approach. What's interesting at their error handling is the fact that the error type can have one of four values that categorize the error. So the four types are internal, validation, security, and configuration. So you not only have the error code, which is a specific code for their code base. You also have a category by using the error type. And finally, similar to what Adyen is using, we have Stripe, where the type can be one of 7 values, and you get specific codes for some errors that could be handled programmatically, and you also can receive decline codes like expired card, incorrect number, or incorrect PIN, where you get more detailed information about why a payment method was declined. More interestingly are the doc URL is very interesting, which returns a URL where you can find more information about the error code that was reported. And the param is also interesting because if the error is parameter specific, the parameter related to the error gets returned. So for example, you can use this to display a message near the correct form field. Okay, enough about other people doing error communication. So if everyone is doing error handling kind of the same, but also differently, aren't there some kind of standards we can use for error handling? The good news is, of course, there are a few standards you can use, and I would like to show them to you right now. The most notable one came with RFC 7807, which defines two new content types for returning error information. The two content types are application problem plus JSON and application problem plus XML. The RFC states that the RFC comes with a predefined set of attributes that one has to return, and you can also extend those attributes. So if your use case doesn't fit in the predefined set of attributes, you can also add more. As you can see, the response contains a type, which is a URI to a definition to that error. The title and detail are short and longer descriptions one can use for displaying the error, maybe in the front end or also for logging. The entries balance and account are extensions of the original set of attributes. So this is what I just talked about extending the attributes that are already out there. So this way you're giving the user agent more detailed information about what actually went wrong. Unfortunately, from my point of view, there are a few things that I don't think are helpful when using this approach. First, the data is not encapsulated in an error object like you saw in the examples I previously showed you. There are error specific, so therefore error specific data and data from the resource that could also be returned, but has nothing to do with the error communication itself, can get mixed. And using this content type, it's more fitting for use cases where you have a single error and then you stop. So when you have an internal server error or some error like that, then you could use application problem plus JSON or plus XML, because after the first error, the processing stops. On the other hand, we have a JSON API, and a JSON API has a very clear definition of how errors need to be defined in an API. Well, one has to stop processing after one error when using the other approach I just showed you. JSON API servers are allowed to continue processing even when an error occurred. This way you can return more than just one error information. And what you can see from this example, they're using JSON pointers to be able to point to a specific entry in a request that was faulty. So this is very good for pinpointing the actual problem where it occurred. Here you can see an example of what it would look like when you return multiple errors in a single response. So the status itself is a resemblance of the HTTP status code. The source contains the pointer to where the actual problem happened, and in detail, in the detail attribute, you find information about what actually happened. And in the second error, you can also see a title attribute, which contains a small, shorter version of the error. Okay, what both of those standards lack is the option to return additional warning information. Not everything can be clearly stated as an error and conveyed through an HTTP status code. So how do we tell the user agent that the initial attempt was successful but had side effects? That is why, together with Eric Wilde, I am currently working on an internet draft called Communicating Warning Information in HTTP APIs. It is our goal to develop a standard that APIs can use for returning warning information. As you can see, the main proposal is a new header field called content warning. It is comprised of two entries, a keyword and a timestamp. For now, the keyword can have a single value, embedded warning, which means that additional warning information can be found in the body of the response. The timestamp defines the occurrence of the warning. Besides the content warning field, we're proposing a predefined set of attributes. The warning entries contain all warning information, and their attributes are based on what is already out there and has been defined in RFC 7808. So what you previously saw in application problem plus JSON also fits in our new draft. This way, we're reusing the standard that is already being used by companies like Adidas and Zalando. As you can see from the header information, the request itself was okay, but it had side effects about which the warnings attribute within the body informs the user agent. One could also return warning information when a server error is returned. So it's just like you would do in a JSON API. To make the intent a little clearer, here are a few use cases we can think of. First of all, the use case where this is actually coming from, the use case that we have ShipCloud have. Some of the shipping carrier APIs are already returning additional information in their responses. For example, the address of a recipient was misspelled and corrected by the carrier. Now one could inform the user agent that the carrier automatically corrected the data. This way, the correct data could either be shown to the user that was making the request or even be saved in a database for future use. Another use case could be debugging. It could be intermediaries. When intermediaries in a request response cycle come into play, for example, caching servers, you could have the use case that the initial request was okay, just like before. Hence, the response wouldn't contain any error or warning information. Now, if anything happens at the intermediary server, one could return this information through warnings that will be added to the response and leave the rest of the response intact. What I just mentioned, another use case could be debugging, because debugging things is every developer's nightmare. Using warning information, one could, for example, return additional data for debugging. A user agent that's set to debug mode could then display this data. All of this while maintaining the normal flow of data to the app. This way, the normal user experience wouldn't be touched by any of what we're actually doing at the backend. And the last use case is something that is very interesting in automations, because when it comes to automations, APIs are at the forefront. Data gets exchanged, and clients as well as servers react to what's in there to automatically do certain things. But having a mechanism for conveying warning information could help in creating finer automations that don't stop because there's an error, but try to find a way to fulfill the original intent. For example, imagine an automation for a calendar app. Someone sends a meeting request without having access to the other person's calendar. The time slot was already booked, so a normal response would be to return an error. Why not let the calendar app return a suggestion for a different time slot using warning information? Thanks for listening, and now I'm happy to be discussing additional use cases as well as your thoughts on the draft and any question that might be out there.